Okay, now we're in our second video of our series of videos covering the different scripts that we use to simulate our adaptation data, process that data, and ultimately do some data visualization and analysis. So we've already created a folder, simulated adaptation data, that contains several subfolders with our simulated data. So what we're now going to do is combine data across our participants. So if we open up the S2_combine adaptation data, the first thing that we're going to do is use CD to move into the folder where our data are stored. We're going to evaluate the selection here. So when we evaluate that selection, what you can see here is that now we're within the folder where all of our participant data are stored. Next, we're going to use something that I use quite often, is that we want to determine how many or what the names are of all of our folders. So if our folders all have the same format, I can search for certain features of those names. So in this case, I know that all of the names begin with the year and then they have some information after. So I want to get the names of all those folders. And I'm going to do so using the dir function. So with dir, I specify the input here within single quotes, and I use this star or asterisk or wild character, and that's going to tell MATLAB to find any file within this directory that starts with 2022. Okay. So if I just highlight this line, evaluate the selection, what we'll see is I now have this new variable directory, which is a structure. And if I type the name of the variable, press enter, we see it's a 20×1 structure, right? So 20 corresponds to the number of folders that we have. And I can access the name of each folder as follows. So I can go directory of one.name, and we see that this is the name of the first directory. So intuitively, hopefully now you can see that if, as I vary this number, I can get the name of these different folders. So if I cycle through from 1 to 20, I can open each folder, load that data, and then combine it all together. So how do we do that? Well, what we're going to do is, again, create a new figure that's going to help us do some of our quality control, pre-allocate space for some certs for our data structure, and then cycle through each folder. So in this case, what I ultimately want to do is think about how I want to store all the data for each participant. And what I'm going to do is I'm going to store that data within something called a data structure. So you'll see this several times through our content here. And in this case, I'm going to pre-allocate the structure in terms of its size and the fields that it contains. So I use the struct command. My first field is going to be SLA, so standing for step length asymmetry. Here we're going to use something called a cell. So this is another variable type. And in this case, I have 16. I should actually we'll make this 20 for now, but we'll correct that shortly so that it accounts for, actually it should be the number of elements in my directory. Okay. So that way it updates based on the size of our data set. Then we'll have fields for variable good data that specifies whether I think the data are reasonable or not, and then the participants' age and weight. All right. So let's just run these couple of lines of code, highlight, right-click, evaluate selection. Now if we go back to our main window, type data, we see that I have a 20×1 structure with these fields. Okay, so there's no information there because we just pre-allocated that space. So now what I'll do is cycle through, just like we've done in the previous video, this variable participant num, and that's going to go from 1 to however many folders I have, in this case 20. And so what I want to do as I go through this loop is I want to save data within my data structure. And so we already saw the format of this data structure. So to access the different fields within my structure, I have my variable name, data, which level I want to interact with, which element. So in this case, I start with the first element, participant num is equal to 1. And then I use the dot indexing here to then refer to the field that I would like. And so in this case, this would be my step length asymmetry. And in this case, the way that we're going to do this is we're going to use import data to import our step length asymmetry data from our CSV. So this is a case where you can imagine that you have data stored as a CSV file. So here, this is a bit of a complex line of code. Okay, so to start, import data is the function that we're going to use, and then the input to this function should be the name and really location of the file that we'd like to import. So let's break this down a little bit. So first, we have this this text here. Okay. So this is just going to be the file name or the directory name that we've already looked at. So this is going to have, for instance, let's imagine that participant num is 1. So let's copy this code, go here, set participant num equal to 1, paste this code, and here's what we get. Right? So it's the name of our first directory where the data for participant 1 are stored. Okay. And so we know that our CSV files have that name underscore SLA.csv. So that's the file name, this part of this line. Now, what we do is I use a function called full file, and that says it tells you the directory and the file name, or it tells MATLAB the directory and the file name. So in this case, the directory has the same name as the file name, more or less. So this bit, the first input, so everything before the first comma, this is the directory that we'd like to look into. And then after the comma is the file name that we'd like to load. So this is a way that you can point MATLAB to a specific location on your computer to import data from a CSV file or an Excel file. Okay. And we're going to store that data, again, in SLA. From there, we're going to plot the data. So we've already gone through this in the initial video where we talked about data, where we're going to do a sanity check to see if our data seem reasonable. And for this, we use an interesting function called quest dialog, or question dialog, quest DLG for short. This is the prompt that we will be presented with. By default, we have a yes or no option, and then we save that information, the yes or no, in the field good data. Okay. And the next thing that we're going to do is just store some artificial made-up information for our age and weight. So we're just going to use generate random integers just to illustrate how we would do that. And then we're going to save all of our data, or excuse me, we're going to save this data structure in a variable, or a mat file called data_all. Okay. So now let's just run this code so you can see it again. So it's here I'm prompted that I'm not in the correct folder. So I'm just going to change folder so go to the right place. And we're just going to click through this. I think that's reasonable. This doesn't really look like a learning curve. Neither does that. That does. Yes, yes, yes. So we're just looking at things where the asymmetry in the beginning is a little bit, should be more negative than toward the end. And this again is just meant to represent some of the variability we might see in real data. So I wanted to go through all that so that we can now look at our data structure. So find type data, press enter. In this case, I now have a 16 by 1 structure. I only had 16 participants in this case. Actually, so if I go data, look at our 10th participant, I have their SLA values, seems like reasonable data, and then the information that we made up for this participant. Okay, so hopefully that gives you a clearer sense of what we're doing here for our the script that we're using to combine our data.